So what we're doing today is looking at centre of gravity. Now there's lots of different terms for centre of gravity. So sometimes it's called centre of mass, sometimes it's called centre of weight. All of the terms, so those three terms, pretty much mean the same thing in most circumstances. We'll talk about that a bit more in the notes. But for all intents and purposes, those are the same. And sometimes when you're looking at plates or anything that's got a shape and a thickness, often the centre of gravity is pretty similar to the centroid, so they're both located at the same position. Okay, so what we'll do is we'll have a look at centre of gravity is what I've usually heard it called, centre of gravity. So in order to understand a bit better what it is, we'll look at some of the different ways that you can find the centre of gravity. So let's start with something like this. This is a ruler. So it's my scale rule, actually. It's about 30 centimeters long. And so again, centre of gravity is basically the balance point for that ruler. So you'd expect that balance point to be in the middle, which should be about 15 centimeters. And you can see that if I support that with my finger there, that's the balance point. So we've pretty much found the centre of gravity for the ruler. One way for doing that is you support it on your fingers and you slowly move your fingers towards each other. And what you'll find is that when you do that, your two fingers will meet approximately at the centre of gravity. Let me do that again. So those things meet at the centre of gravity, which is basically the balance point. Okay. So that's to be expected. If you've got something symmetrical, centre of gravity is pretty much in the middle, and that's always the case. For something symmetrical, the centre of gravity is in the centre. The geometric centre, so the centre of the shape geometrically. Now, that same method of finding the centre of gravity works for things that are irregular. You'll often see this thing where you're bringing your fingers together to find the centre of gravity. They'll use it for a broom. It will work for a hammer too, I hope. And so I'll bring my fingers together. Let's move it out a little bit. And you can see my fingers are meeting at the centre of gravity, the balance point for that hammer. So if I just put it back with one finger just to get it to balance. Okay, and so that's the balance point for the hammer. You found the centre of gravity. So for something like this that's almost one-dimensional, it's not really, but it's kind of long. And so for objects that are one-dimensional like that, the centre of gravity is almost like the pivot point for a seesaw to make it balance. Okay, so let's take a step up now. And suppose we've got something like this box. I'm just going to have to move the GoPro a little bit so you can see this. So you've got something like a box like this, and we want you to find the centre of gravity. To do that, one way is to put a roller underneath it. Just put this back a little so you can see it. And then you can roll that object until you get to the balance point. So I've now found the balance point for that face, which is about there. What I can do then is I can mark that. Just give me a second, I'll just find my pen. So I can mark that point. So that's the centre of gravity on this side. Now in this case it's a symmetrical cuboid, but this would also work for any irregular shape. It'll work as long as you can roll along it. And I've actually used this method of finding the centre of gravity when I was doing some testing on the shake tables. So you're testing for earthquake testing, and I needed to find the centre of gravity so I could put them on the right place, at the right place on those tables. So we found what this means is the centre of gravity must lie somewhere along this line. Okay, but we don't really know where it is yet, so the centre of gravity must lie above that line. We'll talk a little bit more about why that is in a minute. Now, what we can then do is we can turn it over, and we can repeat that process. You have to make sure that the roller is at right angles to the object. Okay, and that's us found the centre of gravity again. As you'd expect, it's in the middle, so this is the balance point. And And so when that's balancing, the center of gravity must be somewhere above the point where the box balances. And usually, and so the center of gravity, if you do it in two positions, you can find the center of gravity, and usually you show center of gravity by drawing a circle and colouring in two of the quarters, and that's showing the centre of gravity. Now, the centre of gravity, we've just looked at one face so far, but we also, when we get to three-dimensional objects like this, so it'll balance this way. Sorry, so it'll balance this way. It'll balance this way. Oh, let me just show you the roller so you can see what I'm doing here. It's just it's like an 8mm or 10mm stainless steel rod. So it's balancing that way, balancing this way. But we also have to think about this way as well. Okay, so we could do the same thing, just have to make sure that the rod is perpendicular to the front face. Move it across until we find where it balances. Mark that on. Draw the line. So in fact, and in fact each of these things, so I have to be careful because I'm just rubbing off what I've done. In fact, each of these things, if you imagine cutting the box, slicing it down the middle, the centre of gravity must lie on this plane. Actually, it's not just the line, the centre of gravity must lie somewhere on that plane. If I go right round, for balancing in this direction, the centre of gravity must lie on this plane. I've drawn it very well. And so actually that centre of gravity is somewhere in, well, it's exactly at the centre of the inside of this box. And I'll maybe try and show you that on Inventor or something like that. I'll show you what I mean. And so the centre of gravity, where all of these different planes intersect, that's where the centre of gravity must be. Okay, so that's another way of finding the centre of gravity. So the first way of finding it was that one where you move your fingers together, works for stuff that's long, almost one-dimensional, and it'll find the centre of gravity, and it's just the balance point, like the balance point for a seesaw or something like that. Another way for 3D objects is you just put a roller underneath, you roll it until you find the balance point, and that defines a plane where the centre of gravity must lie, and you repeat that with the other side. So you find another plane where that centre of gravity must lie, and then a third plane, and where those three planes intersect, that's where the centre of gravity is going to be, right in the middle of the box in this case, because it's symmetrical. But you could do it for some of the units I was testing, they'd be heavier on one side than the other, and so the balance point would end up being off center, but you can still find your center of gravity using that method. Okay, so another method, we're back to this general shape. What I might do is just move the camera a little bit closer. So what we've got is we're back to this plasticine blob. It's been covered in duct tape so I can draw on it. And I've got a couple of points where I'm going to stick the match through it. And what I've got here is basically what would be a couple of slings, so it's just some fishing wire. And so let me see if this works. So I might have to just loosen this a little bit. So, and you can also use this method for larger objects as well. You know, you can just sling them and see what happens, but let me show you why that could be a bit of a problem. So if we have any point and we support an object at that point and then let the object rotate freely, obviously you don't want to do that for something that's too big, it'll find its balance point, and the center of gravity, so you imagine, well, the center of gravity is here. I'm just going to draw it on roughly. So the center of gravity must be somewhere on that line. So why does that work? Well, let's suppose, we don't know this yet, but let's suppose the center of gravity is here. Then when the centre of gravity is over here, it's unbalanced, there's more weight on this side, so it'll always fall down so that it lines up with the sling, so it lines up with the line of support. Now we don't actually know that the centre of gravity is there yet. You can't find out just from slinging in one place, you just know the line that that centre of gravity lies on. If you want to find exactly where it is, you have to repeat that with another point, so another support point. So suppose we support it here, so I've put that matchstick through, we put it on the slings, and then we just allow that object to fall until it lines up. We're going to find another centre of gravity, we're going to find another line that the centre of gravity must lie on. So the centre of gravity must be directly below, we weren't far off actually, directly below that point, and therefore where those two lines intersect, that must be your centre of gravity. Now, if I then, let's see if this has worked or not given how inaccurate it was, if I then put this matchstick through that point, I might have to just sharpen my matchstick, give me 2 minutes, just do that and then I'll come back. So what I've done now is I've just put the matchstick straight through that point, so through what we found to be the centre of gravity. And let's just see what happens. So what does balance mean for a kind of more three-dimensional shape? So for a seesaw or the ruler or the hammer, it's quite easy to see what it means. What it means for a three-dimensional shape is I can turn this to different positions, and it's very sensitive to exactly where you put it, so it might not work in every position. But what you can see is it still stays in the same place, it balances. If I turn it a little bit this way, it balances there too. If I turn it this way, let's just see if it works. It does. Balances this way. So when you find the centre of gravity of a kind of, I guess this is more a two-dimensional shape. The ruler and the hammer were more like one-dimensional shapes. For two-dimensional shapes, it just means that whatever way you turn it, it'll still balance in that location. So for one-dimensional, the seesaw or something like that, you're just finding an X position for that centroid. When you start talking about two-dimensional shapes, you have to find both an X and Y position for the centroid. Now, if it wasn't at the centroid, so let's just stick this through at another random location. Making a mess of my little model, but that's okay. So if I was to put it anywhere else, it wouldn't be the case that it would balance. So if I put it here, and I just see, just a second. There we go. And so if I was to put it like this, then it's going to rotate round. Okay? It's only got one place where it's stable. If I move it up there and let go, it ends up back in that location. You can see the centre of gravity is always ending up directly below the point that you're supporting it. Okay. Now there is one other thing to show, as well as in the balancing like so. What you can also do, it should be the case, that if I put my pen under here at that point, it also balances, and that's not exactly right, but it's pretty close. So I've got the pen under there, it's also balancing that way. If you support it at that centroid, it also balances that way. Okay. That's everything I want to show you for now, so we'll go back to the notebook and we'll have a look in a little bit more detail at what we've just shown with the models.